Hi. Yeah, again, thank you for probably skipping lunch because that was what I had to do after I saw the queue. But yeah, we're at Dachfest, so let's do this properly with a Servus, Grüezi und Hallo. As said, my name is Sebastian. I do work for Deutsche Telekom and basically work on their smart home platform for the past 7 years now. So mainly started out with developing web front ends, and then I did some node services and Python stuff, etc. If you have any questions, because I probably need to leave quite early today, because parent duties, I'm AsciiDisco on Twitter, and the code will be later published on AsciiDisco, my username on GitHub as well. So you can totally come approach me after my talk and ask questions, but if you do not want to for some reason, or you can't, just, well, give me a ping on Twitter. So yeah, as said, I've been tinkering with hardware since about 2011. So that was when I started in that smart home project at Deutsche Telekom. But aside from doing this professionally, I kind of developed a habit of trying to connect everything I can get my hands on so that I can steer it from my computer or my smartphone. I mostly do this by using a Raspberry Pi or an Arduino. And you should probably know I have absolutely no background in electrical engineering. Probably you see that in quite some of the pictures. But also the thing is, I don't need to. I don't need to have a background in technical engineering, because, well, nearly everything nowadays is connected via USB. May it be like adapters for wireless networks, like Bluetooth or Zigbee, I don't know, mobile phones, of course, and yeah, even some interesting stuff like those USB rocket launchers. So, yeah, therefore, as everything can be connected via USB, we're going to talk about USB today, the Universal Serial Bus. Before we get our hands dirty with some real-world devices and some code, let's talk a bit about USB basics and a bit about history. So it all started back in 1994. A few companies, they wanted to, well, basically end or adapt their madness. I don't know if you did computer stuff back then, but maybe you remember you had to plug in keyboards and mice via PS2 ports. You had to connect external drives via SCSI. You had printers connected via parallel ports. Basically everything else connected via the serial port. So to bring all this madness to an end, a group of engineers led by Intel, or led by an engineer from Intel, started developing USB, like one bus system to rule them all. And in late '95, we saw the result of their efforts. So the first USB devices and host systems became available. But they weren't really popular back then, so not really welcomed by the users. In 1998, Apple decided to be the brave ones. They shipped the computer without a floppy disk drive, and more important, without any serial or parallel ports. That was the iMac G3. And yeah, it only had USB to connect things, so that was kind of like really kickstarting that USB movement. In 2010, issues with the slowness of USB were resolved, and the USB 2.0 spec got introduced, as well as the first integrated USB storage device, which was a huge stick with a capacity of 8 megabytes. And well, for many years after that, I think USB was associated with like shoveling data into some stick you can bring to your friends, sharing photos or music. I think that was what USB was associated with like for a long time. The latest major addition to the spec came in 2008, making USB even faster. And as you see, USB is quite an old technology already. So when we're going to talk about APIs and control methods and how to, well, talk to those things, everything will not be very web-ish. It will be like different from the things that we're used to know. It will look a bit alien to us as web developers or as, like, say, modern software developers. because nothing was designed in the USB world with the web in mind. So yeah, you might also probably think that the electrical engineering behind such a complex bus system like USB must be extremely complicated. But to be honest, that isn't. So this is a picture of USB 2.0 plug Type B male. There are, I don't know, quadrillions of different USB plugs out there. But I chose this one because you can see the layout quite well. So we only have 4 pins here and 4 cables in the wire. So let's switch to the schematics to explain that further. So one wire, 1 pin, is used to power the thing. It can take up to 5 volts of power. 2 of those pins and wires are used to, well, transferring data. At first I thought, yeah, probably it would make sense to have like 1 wire for the outgoing data and 1 for the incoming data, but, well, that's wrong. They both basically transmit the same data in both directions at the same time, providing some hardware-based security and transport safety mechanism, which is like really a genius thing to do, especially back in the 90s. Well, and then, of course, we also have the ground pin because we deal with electrical current. When USB was introduced, it was introduced as plug and play. You probably remember that Microsoft keynote where Bill Gates plugged in that USB thing and the blue screen appeared. Yeah. So the thing is, USB is, well, advertised as plug and play, but it often doesn't live up to the claim. I mean, after you bought a device, let's say a printer, because that happened to me lately, it looks like this. You go on and search the internet for a driver. You install some kind of native application. You don't even know if you will need it, if that's needed for the device to work. Well, and then it doesn't work, and you question yourself, oh, is that device actually supported on my operating system? But then you discover that you downloaded the driver for macOS 10.11, but you're running macOS 10.12 now. And yeah, then you finally start to install that thing, and some scary OS pop-up comes up and says, well, you could damage your computer, it could lead to malfunction, you're responsible on your own with this, we don't take any responsibility. Well, and then actually maybe a proper malfunction kills your existing setup and you're not able to print on any printer anymore. And then you try to get rid of all that code and all that stuff you installed, but it kind of sticks around forever. It's just like deep installed in some deeply hidden directories on your computer, and it's very, very hard to get rid of. So, what about, well, I mean, would there be a way that like the technology USB could live up to that claim of plug and play? And I thought maybe it could look like something like this. I mean, you buy a device, you plug it in. We live not in 1994, we live in modern times, so maybe a notification appears like you're used from your smartphone, like you're used to from your smartphone. And yeah, you just then click on it. That opens a website. And then you can have fun because everything works. And basically all you need to do was plug in the device and click on a link that automatically, magically appeared. Wow. Be cool, right? The Chrome team thought so as well. So that's why they created WebUSB, a web standard that enables us to talk to USB devices directly from the browser, directly from JavaScript running in our host system. Few facts though. WebUSB is like all the modern and new platform features only available via HTTPS. This is for security reasons, and like nearly every feature we get on a web platform nowadays only works via HTTPS. And I think that's a good thing. There's no native code of any sort needed. So no need to install any application, no need to install any drivers. It just works because the driver is in your browser. And well, as said, it's like real plug and play. You plug in a device, click a link, and just use it. I mean, university-style location, that was some kind of like university-ish style lectures now, so, well, let's better get to the meat and let's take a look at the code. So, when we want to connect to a device from the browser with WebUSB, we first, well, need to connect to its so-called device descriptor. There is typically only one device descriptor per device, and it provides product information like vendor ID and some other information, and also it allows us to evaluate how many configuration descriptors, we'll get there in a second, will be needed. In order to do this, we just need to use the navigator.usb.requestDevice method. We can apply some filters, because otherwise, you will see later, there will be some pop-up in your browser that will display USB devices to connect to. And for, well, user experience reasons, we want to limit that to devices that we want to connect to. Well, and then, in the end, we just need to call the deviceOpen method, or the open method on the API, which then, in the background, simply runs all the platform-specific steps to start a session with our USB device. And yeah, I've already mentioned config descriptors. So theoretically, a device can have many of them, but usually only has one. And this is due to the fact that, like in the early days, the standard Windows USB driver could only handle one configuration descriptor. And configuration descriptors are there to measure the amount of power needed for the device. It will also determine subsequent descriptors for interfaces. And one thing that's very important is only one configuration can be used at a time. So that is all a bit abstract. So one example from the web world would be you could implement API versioning with those config descriptors, as you do with REST APIs. So you say you have a different, after a firmware update, you have another configuration descriptor you could connect to, and that could present a totally different API or protocol for the device without breaking the old one. So this is one thing that it could be used for. And in JavaScript, we use the select configuration method to actually select the configurator, the config descriptor. So next thing is we need to select and claim an interface. And again, like with the config descriptors, theoretically, a config descriptor can have many interface descriptors. So interface descriptors will basically guide the endpoint descriptors in carrying out specific device commands with multiple interfaces working at once. So, simple example. If you have one of these multi-purpose devices, like a printer that is also a scanner, you could use one interface, or usually it will use one interface for the printing functionality and a different interface for the scanning functionality. So you basically just choose the features you want to use. And in JavaScript, you can use the claim interface method with a numeric value in order to do so. We're getting close to having this all sorted out. So the next thing, after we claim the interface, we are ready to talk to the endpoint descriptors. And the endpoint descriptors will identify details like data transfer direction, polling, and also the types of transfer. And often you see that one endpoint is used for sending data out, one is used for transferring data in, etc. But as with all the other descriptors, an interface can have as many endpoint descriptors as it likes. I mean, there is some theoretical boundary, probably 127-ish, but I'm not sure. So none of the devices I ever toyed with reached that number, reached that limit. So now that we've established the connection to a specific endpoint on the device, we have 3 different ways in which we could communicate with it. So they all come in pairs. So one method for sending data and one method for receiving or reading data. And we'll start with the interrupt transfers. So interrupt transfers are typically like non-periodic, small, and device-initiated communication that requires some kind of specific or bounded latency. So In order to use them, we need to specify the endpoint number for reading and for writing as well. And, well, for writing data, we just then need to have some data, which mostly is an array buffer, because it's all binary here. And for reading, we need to specify a length, so the number of bytes we want to read from the device. In this case, 8 bytes. So this is like in one go what the latest data that is present at the device, we're going to fetch it, the latest 8 bytes. And then we have control transfers, and those are especially nice for like small configuration commands because they have bus priority and they have a well-defined structure. So think about steering signals, like when you have a robot arm, you would probably use a control transfer to move that arm up, down, left, 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 and send those commands over the wire. They do require a bit of configuration though, but don't worry about that yet. So we'll tackle those later when we have a real-world example at hand. And the last type is so-called isochronous transfer. And those are actually very rarely used, and mostly are used for audio and video devices because they can send a persistent stream of data. They do it lossless, so if they skip a few bytes when transferring in incoming audio, nobody doesn't really care. Thing is, they're so rarely used, we won't use them in our examples, and I must admit, I haven't seen them in the wild yet. I haven't tinkered with cameras and microphones yet, because that's a part of WebUSB. But aside from that, I've never encountered these. So please just know that they're there if you encounter them sometime in the future. So, as you see, I brought a few devices with me, and I've done hardware demos in the past, and I have 4 demos, and I'm pretty sure that at least one will break. So now it's time to place your bets, which one. Yeah, but let's see what we can do with that devices. And let's start out with the tinkerer's favorite, the darling device, the Arduino. I've worked with the Arduino in the past years quite a lot, and when I used the Arduino together with Node.js, I used a library called Johnny 5. Johnny 5 is also around since 2011, and it's just a wonderful and easy interface with lots of examples on how to wire things up. I mean, you can basically just start programming your Arduino right away with Node.js. And I kind of like asked myself the question, as Johnny 5 is already JavaScript code, maybe we could use that in a browser as well. So, demo time. Now it gets interesting, and now we should probably mirror the displays. Good. Oh, that's a later one. So what I'm going to do now is I'm going to plug in that Arduino I brought with me. And you see that notification up here? This is because the Arduino has some firmware that is WebUSB compatible. And when I click on that notification after I plugged in the device, I should end up at a web address with, well, controls from my Arduino. So, first of all, I need to connect to the device, which, oh yeah, I've already done. It is already connected. And, well, I've set myself the task to make Johnny 5 running in a browser, and doing so in an interactive console. So, as you've seen, I've just plugged in the Arduino, and now I can basically just start programming right away with Johnny 5. So I instantiate the LED example, and the first thing I will do is I think I will just turn it off, which, well, should work, but doesn't. Yeah, great, as I said, hardware demos, right? That's quite some fun. Let's see if there's a typo, and of course there's a typo because I forgot to initiate it. So now the LED is actually turned off. I can also, I mean, probably see better if I do that. I can also turn it on again. And, well, I can basically use all the methods from Johnny 5, so also the blink method, which will then just, blink the LED. So there are many API examples, and the LED is just like the, tiniest device you can steer. With Johnny 5, you have basically all the sensors, displays, everything at hand, and you can just program them by plugging them into a computer and opening up a web page, which I think is really cool. So back to the presentation. No, I won't start iTunes, sorry. And I don't want to do that, I want to go back to my displays. Turn sync off. Okay, here we go again. So, you might wonder, okay, was it hard, Sebastian? Was it hard to enable the Arduino to be controlled from the browser? And thanks to Browserify, which uses Node modules and is able to swap out some Node.js dependencies and Node.js only modules for browser modules, the browser counterparts, it was actually not that hard at all. So I'm using a fork of the browser serial port library, which was originally implemented for Chrome application, Chrome apps. But there is a fork of it which, exposes the serial port, like the low-level serial port interface, via WebUSB. And after I swapped that dependencies, I was basically ready to go. But I think the serial port is a great example to talk about the different configurations of the control transfers. Because this way, you're basically opening up serial port communication. So I think that's a good example. So first of all, we're starting with the which. So which type of command we're sending. So USB has a couple of standard commands and command types, like class we're using here, that enable hardware to determine what it should, do with our data. So for example, if we supply that request type of class and have a device that adheres to some kind of standard, like printers do, or card readers, or serial port devices, we're kind of ready to use it out of the box. I mean, you have other values like vendor, which then would be totally vendor-specific stuff, and you would read up their docs if they have any to do proper implementation. But then we have to tell our WebUSB with whom we're going to talk. And we're going to talk to interface node. I mean, it could be an endpoint node as well, but we need to talk to the interface node in this example. Then we have to, tell the device what we want to do. Send a command, invoke a command. And this one is just, please open up the serial port communication. So that's usually represented by some hexadecimal numbers. We can also send a value with it. And, if we go back to our example with the moving robot arm, we could basically use that value in the control transfer if we have a device that speaks the protocol we have defined to, determine if we go up, left, down, right. So send some configuration, some value with our request. And in the end, we have the whom again, the index, so which interface node we're going to talk to. In this case, it's interface 2. So a bit of configuration needed, but it's quite easy, I'd say, to figure this out if you have a device, especially if that device has a proper specification or there's some code written in other languages for that device as well. Well, then, basically, we had Node code running in a browser. We were able to, work with the device in a browser as it would be from Node.js. And I think that's cool because there's nothing scary about that. It removes all the scary parts of setting up an environment because all you need to do is to connect the device and all the hard setup steps are just gone. So, next demo. This is actually the one that, fails most of the time. So, I have some really cheap Android tablet with me here. And wonderful Android sound, yeah. I must say I'm an iOS person, sorry. And, What we're going to do now is, first of all, we're going to take a picture of the audience, which is kind of hard because we have some flashy lights, but, oh well, it will work. So, great. Now this guy took a picture from us, you might think. What is he up to? Plop. What I'm actually up to is I want to connect to that Android device with WebUSB and access it via the Android debugging bridge, ADB. Well, let's see if that works. Let's go back to a browser. And, well, I should keep that display thing open. Sync the monitors again, and open up a browser. And that one should be running on localhost 82, okay. So, let's do it that way. That is the beautiful picture I took just a minute ago. Oh, there's even more. You probably won't see much now, but let's fix that. Maybe there's a way to transfer that picture to a browser and display it on a big screen. Well, first thing I have to do is connect to the device. That is my Android device. All right? Then it asks me if I want to activate the debugging, and of course, yes, I'll do. Next thing I'm going to do is list the files in the storage for the camera, and this should be the picture that I've just taken. So next thing I'll do is I'll press download and see if I can actually download this picture to my browser. And yeah, here we go. Horrible picture because of the lights, but this was basically the picture I've just taken with this tablet before I connected it to my browser. And there's no server-side code involved. Everything runs in the browser. I've just activated the debugging mode and, well, connected to it. So, let's go back to a presentation and see how I did that. Well, as said, I've used the Android debug bridge, the ADB tool. So ADB is a defined protocol. You can read all of that stuff up, and then you could, well, it's basically just a matter of taking that specification and turning it into code. I must admit, there is some complexity to this protocol, and we don't have time to dive deeper into that. But, well, this just simply roughly illustrates how you would construct a message that gets sent over the wire. Well, if you don't want to go down that rabbit hole and implement ADB yourself, well, consider yourself lucky, because a few people, also people from Google, already built a library for this, which is called WebADB.js. And it makes accessing those Android devices as easy as doing this. I mean, with that library, we basically can do anything that regular ADB allows us to as well. So we can have full Unix shell access from the browser on the Android device. We can upload APKs. We can, as we've seen, access all the user data, the whole file system. And that should ring a bell, because wait, access all the user data, upload APKs? Haven't those people, well, thought about security when they came up with WebUSB? Well, I mean, of course they did. So, as you've seen, if you want to connect to a device, you can only do that when invoked by a user gesture. So you always need to have a pointer, mouse, some event you trigger as the user to open up that connection dialog. There's no other way. There's no programmatic way to invoke that. And then you have to explicitly grant permission by choosing the device and clicking OK to connect it. Also, WebUSB, the spec, doesn't allow to interfere with cameras, microphones, or USB mass storage devices directly. So that is just simply not possible. And as I've learned from Niels, who's going to be the next speaker and talks about Web Bluetooth in a podcast he's done, apparently there's a kill switch in Chrome that the Chrome team can flip over if, well, some big security issue or vulnerability is discovered, as they did like roughly a year ago with the YubiKey two-factor authentication USB devices, because you apparently were able to read out, I think, the keys that were stored in that device via WebUSB and kind of like defeat the whole purpose of that two-factor authentication device. And what happened then was that someone from Google at the Chrome team kind of like flipped the switch and disabled WebUSB in all of the browsers out there. So no WebUSB anymore until they fix it with the next browser revision. But yeah, apparently there is a thing. You can, well, have mixed feelings about that, but in the end it's a good thing because it's about end-user security. Going on with the demos. So, as I do work professionally in the sector of IoT and smart home, of course I, well, brought some smart home devices with me. Well, tiny ones, I'd say. Everything in there? Right, good. So, I want to connect devices that use two different wireless protocols together using WebUSB. So, I have, to be more precise, I have this light switch here that you can glue on your wall, which is just a simple light switch. That is connected via the Enocean protocol. Interestingly, the company behind Enocean, who does the spec, is quite close, and quite close to Munich, so quite close to here. And that is just a very well-defined protocol for connecting wireless IoT or smart home devices. And you could use development dongles like this to, well, have a bridge from USB to that wireless protocol. And then I'm going to use that light switch to turn on and off a Bluetooth bulb. Well, the Bluetooth bulb is connected via the Web Bluetooth standard, which, well, if you're interested in that, you should definitely stay for the next talk. I'm not going into details about that. All right, so third time's a charm, demo time again. So here we go. Let's just see if we have, here's the light bulb. And first of all, I need to connect to my USB Enocean dongle. Okay, did that. Then I need to connect to the light bulb. Oh, yeah, thanks. Just, yeah. I was kind of like afraid that I will forget that every time to sync the screens again. But yeah, here we go. So there's the light bulb. I've connected everything, and let's see if I can flip that switch and turn it off. Well, kind of like it receives the signals, and here we go. Now it's off. I can do it again, turn it on, turn it off. It just, well, just seems like it takes some time to transmit the signals, but generally it's working. So I hit the switch, and it will just take some time. Or it doesn't work at all sometimes. Well, but you've seen it worked a couple of times. I must admit, I haven't implemented the whole Enocean protocol, just the parts I thought I need. And well, maybe some parts I kind of need, I forgot. So one more chance. You also need to have a distance to that dongle, but not that far, and also not too close apparently. Yeah, well, I'd say something broke, but in the end it worked at least 2 or 3 times. Still is great outcome. Yeah. So a lot of monitor switching today, but here we go. So connecting to that USB stick was quite easy because it supports the serial port protocol, and basically I've already had all that connecting to serial port code from the Arduino example, which uses that as well, or at least Johnny 5 uses that in the background as well. And then it was like all a matter of taking the data and, well, encoding that data to be a string. And I mean, the problem with the Enocean protocol, I mean, it's extremely well designed. So those that light switch here, it has no battery. All the power that it needs for transmitting the signal is generated by the kinetic, well, press of that button. Unfortunately, and fortunately for me, the power that is generated by this kinetic press isn't enough for any, well, let's say, cryptographic things. So, well, all this that goes over the air is just plain text or plain binary, and in the end, all I need to figure out which button of that switch has been pressed was like parse out a specific part of that substring that I encoded. So that was fairly easy. One thing, as USB, as said, wasn't designed with the web in mind, it doesn't have any event handler mechanism or such by itself. So instead, we kind of like need to build one on our own. And this is an example of a simple like read loop that just goes on and on. I think Stephanie just also showed that with her connected close example. So it just constantly reads data from one endpoint of the device and emits that data, and then it calls itself again. So it's just going over, reading data until there's some error, like removing a device would trigger an error because it can't read then from it anymore, and then it just stops. So this is like a very, very simple way of data polling from USB, and basically nearly everyone who works with USB devices seems to do that. Okay, last demo. This will involve quite a few devices. We've only tinkered with like one or two. This actually will connect 3 devices, because we're going to build a public library checkout system using RFID cards, a barcode scanner, and a receipt printer. So I just need to just plug in some of the devices. And it's like, I would have loved that stuff as a kid. I mean, having this stuff you only know from shops, it's like just pretty cool. It's actually quite cheap to get on eBay. I think the printer and everything also makes wonderful noises. Was just like, printer was like 15 euros, that thing, the barcode scanner was 10 euros. So it was just really cool and really cheap to start playing with it. So it's switching monitors and syncing monitors time again. And let's head on to our last example. Okay? So let's connect. Oh, maybe I should also plug in the printer, because otherwise you can't connect to it. Here we go. That's really a simple standard printer. And the first thing we need to do is we need to identify, and I should really mark those cards because, well, okay, that wasn't the right one. Maybe that was? Yeah, that was the right RFID card. Great, so now I've authenticated at my library, at my tiny library. And next thing I'll do is I can read out the barcodes from those books. This is one of my favorite books, JavaScript, The Definite Guide, the edition from 2002. It covers JavaScript version 1.5. Definitely something you should read. So let me see. Okay. I just scanned it, and it should show up here. Oh yeah, there we have it. Maybe it's also because of my slow internet connection, because I've hooked it up to an online API which takes the ISBN number I'm reading from the barcode and turns it into actual information about the book. So another book I really like is Secrets of the JavaScript Ninja. So I want to have that as well. And here we go. So, great. I think those 2 books are enough. Let's just print my receipt, and great, here we go. My tiny public ad hoc library works, as expected, fortunately. Oh, great, and there's no more monitor flipping, and I'll be done in a sec. Great. So yeah. Printer, connecting to the printer was actually quite easy because that adheres to a standard. And I not only need to encode all the text after I connect it to it, use transfer out on the right endpoint, and it just instantly prints. I was really surprised with that. The other two devices, it was a bit harder because they belong to a special group of devices, human interface devices, or short HID. While keyboards and pointer devices belong to this group, as well as many older devices who only need to transfer numbers and text, like the barcode scanner or the RFID reader. So HID devices will not be part of the WebUSB spec, part of the API. They'll use a new one, which might look like this, but as of today, no browser implemented it. But the Chrome team is working on making that API reality. So the reality is just as those are just keyboard devices emulating keyboards, you kind of need to do this ugly thing, and you should never put that into production. At least you know what you're really doing. So basically just scanning for all the key presses with a global handler, and then just trying to decide from which device everything came. But yeah, generally, demos kind of worked well. A bit relieved, to be honest. And if you want to start with tinker with WebUSB and USB devices, check out the -- device log Chrome developer feature, because you can see all the devices, including the events, vendor and product IDs, also Bluetooth devices, not only USB devices you've plugged in. If you don't have a device or want to test your code, you can go to USB internals and basically generate some bogus devices that can be used for testing only. And sadly, we only have WebUSB in Chrome. And other vendors already expressed that they're not so fond of the spec, and well, mostly because security concerns. But the thing is, I think one browser is already enough for our specific use cases. There's also an NPM package called Node WebUSB, which allows you to use the WebUSB API from within Node, so effectively turning WebUSB into a cross-platform spec. Few things you should take away. So WebUSB lets you, browser developers, write your own drivers for devices. As we've seen, we can build plug-and-play systems like a checkout system for shops. No need for extra software, no need to install software. You can use an Android tablet and hook up the USB devices, and it just works. Instant shop checkout system, maybe connected to a warehouse management system. It makes it super easy to start tinkering with hardware, like think about schools or in the Coder Dojo. So no hard setup steps for beginners. You just plug in devices and play with them, like with the Arduino. I wish we had that when a lot of kids in the Coder Dojo in the past years just showed up with Android tablets and they wanted to start work with hardware and program hardware, but with just an Android tablet, it's kind of hard. We can write drivers that are truly isomorphic, that work in the backend systems as well as in our front-end systems. And, well, the most important thing is we're improving the lives of the end user, bringing USB to that state of plug and play it always should have been. And as developers, of course, we can just have lots of fun, build shitty robots and stuff, which is the really, truly most important thing, having fun. So, yeah, thank you very much. And questions later, I'll be outside after I enjoyed Niels' talk. Thank you.